my dear students. This is our fifth video of chapter 2 inverse trigonometric function of class plus 2. This is Amanpreet Kaur. Before starting with this new questions, I just want you to go through with the formulas again. Let us revise these formulas again which we have done. These formulas: sine inverse of minus x is equals to minus sine inverse x. Tan inverse of minus x is minus tan inverse x. Cosecant inverse minus x is equals to minus cosecant inverse x. I already told you these sine, tan and cosecant and friends, and cos, cot and secant are friends. So whenever they have the negative signs, we will put minus pi minus cos inverse x, pi minus cot inverse x, and so on. And we knew this: sine inverse x plus cos inverse x is equals to pi by 2. Tan inverse x plus cot inverse x is equals to pi by 2. Secant inverse x plus cosecant inverse x is equals to pi by 2. And very important thing that we have done, that is principal value branch, right? These are the inverse trigonometric functions, these 6, and we have done the principal value branch of these questions. Why today again I am taking this formulas? Because now whatever questions we are going to do, it plays a very important role. Principal value branch plays a very important role. Sine inverse sine of 2 pi by 3. This is the question, right? Sine of 2 pi by 3, this is the domain of sine inverse function. This is the domain. Answer range we should get between minus pi by 2 to pi by 2, right? It is closed interval. The domain is minus 1 to 1. Obviously when we will solve this sine 2 pi by 3, the answer will be in minus 1 to 1, right? This is domain. And after that we should get the range, principal value branch, between minus pi by 2 to pi by 2. But once if we say sine inverse and sine, this cancels. The answer is 2 pi by 3. Do you think this 2 by 3 belongs to minus pi by 2 to pi by 2? Do you think so? Definitely no, right? So it means there is some typical method to solve these types of questions. It will be done if the answer will be in between the range. So how to do these type of questions? These types of question can only be done if you know that principal value branch, if you have learnt thoroughly. And I told you how it can be done. Sine, tan and cosecant are friends. Their range is between minus pi by 2 to pi by 2, right? For sine it is closed interval, for tan it is open interval, and for cosecant it is closed interval except 0. Cosecant, cot and secant are friends. Their range is 0 to pi. For cos it is closed function, for cot it is open function, and for secant it is closed function 0 to pi except pi by 2. This is what you have to learn. You have to keep it in mind. Now let us move on with the questions now. If you see question number 16 of your book, question number 16 is that function sine inverse 2 pi by 3, right? Sine inverse 2 pi by 3. See, this is your question number 16. Sine inverse of sine 2 pi by 3. If you put sine inverse and sine cancels, the answer should belongs to principal value branch, that is between minus pi by 2 to pi by 2, right? This is our question. But 2 pi by 3 does not belong to this, right? So how we will be doing it? We knew that sine inverse of sine 2 pi by 3 can be written as sine inverse of sine. 2 pi by 3 can be written as pi minus pi by 3. Yes, it can be written like this. It is in second quadrant, right? So this becomes sine inverse sine of pi minus theta. You know the formula, that is sine theta, because it lies in second quadrant, and in second quadrant sine is positive. So it becomes sine pi by 3 now, right? So sine inverse sine cancels, we get answer is equals to pi by 3, and this pi by 3 belongs to closed interval minus pi by 2 to pi by 2, right? So this is your answer. The question is find the values of each of the expression in exercise 16 to 18. So we cannot simply write the answer is 2 pi by 3 because it does not belongs to the range of sine inverse. The answer should lie in the range of sine inverse. This is inverse trigonometric function. I hope this is clear to you now. So this step is very important to mention, that this belongs to principal value branch of sine inverse function. Moving on to the next question. Next question 17 is tan inverse tan 3 pi by 4. And what is the range of tan inverse, or you can say principal value branch of tan inverse? Again I say the principal value branch of tan inverse is open interval minus pi by 2 to pi by 2. Right? So this is 3 pi by 4. This does not belongs to, this is in second quadrant. This does not belongs to this because it lies in first as well as in the fourth quadrant. So how to proceed with this question? So we can write it as tan inverse of tan. Again I can write this function as pi minus pi by 4, right? I can write it tan inverse tan, because it lies in second quadrant. 3 pi by 4, numerator is less than denominator, so it means second quadrant. So now in second quadrant tan is negative, so our next step is tan inverse tan of minus pi by 4. Tan of pi minus theta is tan of minus theta, right? So next, tan inverse and tan cancels now. Minus pi by 4 and minus pi by 4 belongs to interval this fourth quadrant. So the answer is equals to minus pi by 4. Minus pi by 4, and you will write this belongs to open interval minus pi by 2 to pi by 2. Right? So you should know what is its principal value branch, only then you can be able to solve the questions. Moving on with the 18th question now. In 18th question, you will see, this is question number 18. Here you will see find the value of tan sine inverse 3 by 5 plus cot inverse 3 by 2. Here you will see this is not tan, right? So what I am going to take this as x and this function as y. Sine inverse 3 by 5 as x and cot inverse 3 by 2 as y. Now I got sine inverse 3 by 5 as x. So bringing sine to x side, it becomes sine x is equals to 3 by 5. Now let us see this. This is our 90-degree angle. Sine of any angle is perpendicular upon hypotenuse, right? So what is perpendicular here? Let us say this angle as x. Perpendicular is 3 and hypotenuse is 5. Right? So after applying Pythagoras theorem, you will get base as 4. Right? We want this term in terms of tan because outside there is tan. So what is tan x now? Find out tan x. Tan x is equals to perpendicular upon base, so it becomes 3 by 4. So we have converted this sine inverse 3 by 5 in terms of tan. So this will become, what is x now? That is tan inverse 3 by 4. So it becomes tan inverse 3 by 4. I hope this is clear to you now, right? It becomes tan inverse 3 by 4. So let us write it here as it becomes tan inverse 3 by 4. Now coming to this, cot inverse 3 by 2. Let us say cot inverse 3 by 2 is equals to y. Therefore what I get, cot y is equals to 3 by 2 again. we can apply Pythagoras theorem here, right? What is cot x? That is base upon perpendicular, right? So this is y, this is 90 degree, base is 3 and perpendicular is 2, right? After solving, you will get what? You will get hypotenuse as, you will get hypotenuse. Is there a need to get hypotenuse? No need, because we want the function in tan. So cot y is a reciprocal of tan y. So what is tan y? Tan y is equals to 2 by 3, right? Perpendicular upon base. So what is y? Y is equals to tan inverse 2 by 3. Is it clear, everyone? We have done in class 10 how to convert a sine theta in terms of other trigonometric functions. Same we are doing here also. This is class 10th work, right? Now we have got y as tan inverse 2 by 3. Let us write this again, right? So now after that, what we have concluded, the function becomes this. We have put the value of sine inverse 3 by 5 as tan inverse 3 by 4, cot inverse 3 by 2 as tan inverse 2 by 3. This becomes tan inverse x plus tan inverse y, and the formula is, we have done so many questions regarding this formula, so we will apply the value. First we need to check whether xy is less than 1 or not. Let us check. 3 by 4 into 2 by 3, right? Cancels, it becomes 1 by 2. So this is less than 1. So applying the formula, you will get answer as 17 by 16. Very, very important question. So keep this thing in mind that you can convert sine inverse, cot inverse in terms of other inverse trigonometric functions also, right? So rest of the questions of this exercise, you will be solving it yourself. So moving on with miscellaneous exercise now. Question number 1. Find the value of the following: cos inverse cos 3 pi by 6. This is your question number 1. We know that the range or principal value branch of cos inverse is 0 to pi closed interval, right? Here 13 pi by 6 belongs to first quadrant. How? We can write this cos inverse of cos 13 pi by 6 is equals to cos or inverse of cos 2 pi plus pi by 6. We can write it like this: 13 pi by 6, 2 pi plus pi by 6. Now 2 pi plus theta belongs to first quadrant. So in first quadrant everything is positive. Every trigonometric function, inverse trigonometric function, is positive. So this is equals to cos inverse of cos pi by 6, right? So what is the answer here? Pi by 6. And we know that this belongs to the principal value branch of cosecant cos inverse function. So the answer is pi by 6. This is the question. In 3 steps this question is done, right? So similarly, question number 2 also is the same thing. You need to know what is the principal value branch of tan inverse. The principal value branch of tan inverse is open interval minus pi by 2 to pi by 2. So you will do it yourself. Moving on with question number 3 now. Question number 3 is, you have to prove that 2 sine inverse 3 by 5 is equals to tan inverse 24 by 7. It means you have to prove left hand side is equals to right hand side. Now let us take left hand side. What is left hand side? That is equals to sine inverse 3 by 5. Let us take this as theta, right? So this implies sine theta is equals to 3 by 5. This is angle theta, right? This is perpendicular 3 and hypotenuse is 5, right? So after applying Pythagoras theorem, you will get base as 4. Now convert this tan theta. So what is tan theta now? Tan theta is equals to perpendicular upon base, that is equals to 3 by 4. So what is theta? Theta is equals to tan inverse 3 by 4, right? So you got tan inverse 3 by 4. Right, now what is our question? 2 sine inverse 3 by 5. We have got this theta is equals to tan inverse 3 by 4. Now let us solve. What we have got, theta is equals to tan inverse 3 by 4. Now left hand side, 2 sine inverse 3 by 5, it implies 2 theta. Therefore 2 theta is equals to 2 into tan inverse 3 by 4, right? So 2 tan theta, tan inverse theta, what is the function? That is equals to, what is, applying tan on both sides. Applying tan on both sides, what you will get? Tan 2 theta. Let us take tan on both sides. Tan 2 theta is equals to, right? Tan 2 theta is equals to 2 tan theta upon 1 minus tan square theta. This is the formula. So you will apply the value, that is equals to 2 into, what is tan theta? That is equals to 3 by 4 upon 1 minus 3 by 4 whole square, right? After solving, you will get this is equals to 24 by 7, right? So what is 2 theta now? 2 theta is equals to tan inverse 24 by 7, which is equals to right hand side, right? So this way you will solve the question. You have to convert sine inverse to tan inverse. Please keep it in mind, sine inverse to tan inverse, and conversions you have done in class 10th also, right? So this question is easy question because there is. Now moving on with the fourth question. What is this fourth question? Sine inverse 8 by 17 plus sine inverse 3 by 5 is equals to tan inverse 77 by 36. Question number 4. Prove sine inverse 8 by 17 plus sine inverse 3 by 5 is equals to tan inverse 77 by 36. So what you have to do here, you will convert this into tan inverse, right? And other function again sine inverse, so you will again convert it into tan inverse. This is x, this is y, let us say. So in between there is plus sign, so tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus xy. So you will apply this function. Now you know how to convert, right? So simply you will convert it into tan x, then other one you will take as tan y, so apply the formula. This is the hint of this question. I hope it is clear to you now. Moving on with the next question. In the next question, cos inverse 4 by 5 plus cos inverse 12 by 13 is equals to cos inverse 33 by 65. So what you will do here in this question, first is cos inverse 4 by 5. So you will take this as x, right? And this as y. So now solve it. Cos inverse 4 by 5 is equals to x. So cos x is equals to 4 by 5, right? Next, cos inverse 12 by 3. Next is cos inverse 12 by 3 13 is equals to y. So this implies cos y is equals to 12 by 13. From here find sin x. Why? I will tell you sin x. What will be sin x now? So once you will apply this, this is your base, hypotenuse, you will find it as 3. So sin x will be 3 by 5. And here find out sin y. What will be sin y? So here this is your 12 base, this is your 13 hypotenuse, and what will be your perpendicular? Yes, what will be your perpendicular? Find out fast. Hurry up, all of you. Your perpendicular will be 5, right? So sin inverse y is equals to 5 by 13. This you will get, right? Kindly make a note of it. What is sin x, cos x, sin y, cos y, right? Now let us move on with the question. We have taken this as x and this as y. So what is x plus y now? X plus y is equals to this thing, right? We have taken left hand side now. Taking cos here. So what is cos of x plus y? What is the identity of cos a plus b? That is equals to cos a cos b minus sin a sin x sin y, right? We have taken all the values, we have find out all the values, so we will put the values here and we will get the answer, right? So whatever the answer, after solving you will get the answer is equals to 33 by 65. This is how you will be solving after putting the value. Then we have taken this cos of x plus y. Taking cos to the right hand side, we will get x plus y is equals to cos inverse 33 by 65, which is equals to your right hand side. In this way you will solve the question. Why I have not converted it into tan? Just because I have seen my right hand side. Right hand side is cos inverse and the question is also cos inverse. So if I have taken x and y, so I will apply the identity of cos x plus y. So what is the identity of cos x plus y? That is equals to cos x cos y minus sin x sin y. So which value I need it? I need sin x and sin y. So I have found out those things. Question number 8 now. Question number 8 is tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8 is equals to pi by 4. There are 4 terms in the left hand side. So here you can take 2 terms first and then third and fourth terms together. This becomes tan inverse x plus tan inverse y, right? And we know that 1 upon 5 into 1 upon 7 is equals to 1 upon 35, which is less than 1. Same here, 1 upon 3 into 1 upon 8 is equals to 1 upon 24, which is again less than 1. So we can apply the identity here simultaneously. So this question number 8 now, see here, in this question number 8, we have taken tan inverse 1 by 5 plus tan inverse 1 by 7. Applying the identity, this identity tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus xy. You got the answer is equals to tan inverse 12 by 34. After cutting you got tan inverse 6 by 17. Simultaneously you have applied the identity on this function tan inverse 1 by 3 plus tan inverse 1 by 7 and you got this answer. Again this becomes tan inverse x plus tan inverse y. Now again you have to check whether 6 by 17 into 11 by 23 is less than 1 or not. So yes, it will be less than 1. So after solving it you get the answer tan inverse 1, right? So when is tan inverse 1? 1 is when angle is pi by 4. So this is your right hand side, hence solved. Moving with the next question on the next page, question number 9. Question number 9 is tan inverse x is equals to half cos inverse 1 minus x. This is your question number 9. What you will do here in this question, since see the right hand side, the left hand side is tan inverse, right hand side cos inverse, it means we have to make this function as function of cos, right? So what we will do, we knew that how can we make it 1 minus tan square theta upon 1 plus tan square theta that is equals to cos 2 theta, right? We know this cos 2 theta is equals to 1 minus tan square theta upon 1 plus tan square theta. Here in place of tan square theta I have x, so I got the hint, I will put x is equals to tan square theta. I hope this hint will make you understand which function you have to take so that the question becomes easy to solve now. So now x is equals to tan square theta, right? So square will be taken on the left hand side, it becomes root x is equals to tan theta and hence theta is equals to tan inverse root x. You have got the angle. So 1 minus x upon 1 plus x is equals to 1 minus tan square theta upon 1 plus tan square theta, which is equals to cos 2 theta. So putting the value cos 2 theta here, you will get cos inverse of cos 2 theta. You have taken right hand side, so it becomes half of 2 theta. Half of 2 theta is theta, that is tan inverse root x, which is your left hand side. Hence this question is solved, right? So isn't it easy? Yes, it is easy once you know what value you have to take so that it can be solved easily, right? So moving with the question number 10 now. In the question number 10, question number 10 is cot inverse square root of 1 plus sine x plus square root of 1 minus sine x and divided by 1 plus sine x square root minus 1 minus sine x, right? So this question seems to be tough because so many terms are inside and outside there is cot inverse. So what you will take this function? How will you solve this function? Now you knew that you have to rationalize, right? So rationalizing the denominator, you know how to rationalize? Yes, you know how to rationalize. So rationalize the denominator. It means what you will do here, you will multiply it by square root of 1 plus sine x. Since here it is minus sine, so you will take plus square root of 1 minus sine x, right? And in denominator also it will be same. So after rationalizing, you got the value 1 plus cos x upon sine x. Now 1 plus cos 2 theta is equals to 2 cos square theta, right? So here half angle formula, that is 2 cos square x by 2, and denominator also half angle formula, 2 sin x by 2 cos x by 2. 2 cancels with 2, cos cancels with cos, so you got cos upon sine, that is cot x by 2. So cot inverse of cot x by 2, that is equals to x by 2, which is equals to your right hand side. It was looking that this question is typical, but reality is this question is the easiest one. You, because in ninth class you knew that how to rationalize the denominator. Once you have the terms with the difference of signs, then you need to rationalize the denominator. This is how question number 10 will be solved. Moving with the question number 11 now. Question number 11 is tan inverse 1 square root of 1 plus x minus square root of 1 minus x. Isn't it the same like question number 10? Yes, it is same. But is there a need to do rationalize? You can rationalize, but at last you have to put the value of x, right? So here half angle formula. So I have taken here x is equals to cos 2 theta, right? After taking x is equals to cos 2 theta, I have put this, right? So what is this half angle formula? 1 plus cos 2 theta is 2 cos square theta, right? And 1 minus cos 2 theta is 2 sin square theta, same in the denominator also. So square root of 2, square root of cos square theta becomes cos theta, so it becomes square root of 2 cos theta, square root of 2 sin theta, and so on. Square root of 2 taken out cancel, you will get tan inverse cos theta minus sin theta upon cos theta plus sin theta. Dividing the numerator and denominator by cos theta, you will get cos theta divided by cos theta 1 minus sin theta divided by cos theta is tan theta. So 1 plus tan theta, right? And this is the formula of pi by 4 minus theta, tan of pi by 4 minus theta. In the previous exercise also we have done one question related to this, right? So tan inverse of tan pi by 4 minus theta becomes pi by 4 minus theta, right? This becomes the answer. And what is theta here? Theta, you can put the value from this. So isn't it easy? Yes, these questions are easy. Once you know the trick, this chapter becomes very easy to solve, and believe me, you will get full marks after you understood the formulas and after you understood the trick, which question, in which question which trick is to be applied. And almost in all the questions the trick is same, right? The trick is same. Now once you understood this question, I think 4 to 5 questions are left which are easy. Now you can solve the rest of the questions yourself.